We are going to look at increasing and decreasing functions in this section and even and odd functions in this section. So let's take a look. Let's get started here. The first definition there is a function is increasing on an interval I if for any x1 and x2 in the interval where x1 is less than x2, then f of x1 is less than f of x2. Well, that's a mouthful and a lot of math speak. Let's see if we can break it down a little bit. Here's what we are saying. A function is increasing, and this is going to be very intuitive to you. When x1 is less than x2 is referring to this situation where you have x value left of another x value. So we're talking about going from left to right, x1 being smaller than x2. Then f of x1 less than f of x2 means the y value is smaller. So you have a smaller x value, meaning you're further over to the right, to the left, giving you a smaller y value. So you're going to have an increasing function. That's what that means. That's the mathy language there. Decreasing is similar, except that as you move from left to right, from x1 to x2, the function goes down because the second value has a smaller y value. And then constant, of course, equal. Let's take a look at an example here. Hopefully that's not a surprising definition to you, what it means for a function to be increasing. As you move from left to right, going up is increasing. So here it says determine the intervals on which the following function is increasing, decreasing, or constant. Let's start with, we'll do increasing in orange. As we move from left to right here, the function is going up. So it's increasing up to that point. Same thing here along those values. So we would say this function is increasing on, so it's determine the intervals. So it doesn't say this here, but we're going to assume there's an arrow on each end of this. I actually wrote this function and it is a function with domain negative infinity to infinity. So there are arrows on the end there. So we're going to say negative infinity until, okay, what is that x value? We're approximating here. It seems like it's a little bit to the right of negative 0.5, so maybe negative 0.4 here. Going up a little from there to that peak there, maybe. Okay, and then we're increasing again from 1 to that peak. Let's go down and see where we think we are there. X value we're at here. Notice we're talking about x values. Maybe 2.4. Probably a better language here instead of determine would be approximate. Just to make sure that we understand that we don't really know just from the graph. And then decreasing is everywhere else because there is no place that this function is constant. Constant would be if it went straight across horizontally. Let's go with green for our decreasing. That's this part here. And it switches straight from increasing to decreasing. So we're going to use these same numbers, the negative 0.4 to 1, and then from 2.4 to infinity. So we have covered our entire domain, negative infinity to infinity, with the exception really of those actual peaks and valleys that we have there. Okay. Those peaks and valleys have an official math name. A value f of a is a relative maximum of f if there exists an open interval around a such that f of a is greater than f of x for all x in that interval. That means that point, that y value, is bigger than the rest of the function. Same thing here, but now we have f of a less. That f of a is less than all other points. So it is a minimum. That's like a valley. Think of this as like a peak and this as like a valley. And it just has to be in some interval around there. It doesn't have to be what we would call the absolute max or the highest point of the whole function. It would just be around that point. It's the highest. Let me show you what I mean here. So these 2 points up here, this guy, I'm gonna grab another color. This guy here appear to be, are both relative maximums because they are bigger than everything around it. If you look at all this area right around it on the function, it's higher than that. Same thing over here. So I would say we have a relative max at, that was negative 0.4 was what we said the x value was. And then that y value, 4, let's go back up there. We had said it changed at negative 0.4, that's why I'm using that as the x value. And then the peak, the y value there is 4. Same thing over here for this one. This is that ordered pair 2.44. So that's also going to be a relative max. As far as a relative min, let's take a look here in this picture. We have a minimum here in that everything around it, these values all around it, are all bigger than it. You may look at that and say, but that's not the minimum of the function because these areas over here are smaller than it. And you'd be correct. That's why this, we would not consider that point to be an absolute minimum. It's not the most minimum point, but it is what we call a relative. Sometimes we call those local mins also. So just be aware of that. This would be a relative min at, what is that point? 1, 0, it looks like. X value 1, Y value 0. Okay, that's how we find mins and maxes. Over here, these values that continue on down forever, because it continues on down forever, you don't get a min out of those because it doesn't ever turn back around such that you have that valley. Okay? The last topic we're going to look at in this video is even and odd functions. The definition of an even function is that when you replace x with negative x, you get back the original function. The definition of an odd function is when you replace x with negative x, you get the opposite of the entire function. What we know about even functions is that they are symmetric about the y-axis, and an odd function is symmetric about the origin. What we mean by origin symmetry is if you were to pick that graph up and rotate it 180 degrees, so a half circle around the origin, you have the exact same picture as what you started with. So an example of this might be the line y equals x that looks like this, that goes through the origin. If you pick that up and rotate it at 180 degrees, this, my colors, there we go. This part would move down and would go on top of that. And this part here would move up to here. And so that's what we are referring to when we talk about origin symmetry. Doesn't have to be a line. Lots of functions have origin symmetry that are not linear functions. We'll see some examples here. Let's take a look and determine if these are even, odd, even, or neither. The way we actually determine that, we could look at them on a graph, but the way we actually determine that is by using this definition right here. We figure out what f of negative x is. That means everywhere in this function that you see an x, you replace it with negative x. And then simplify, and if that simplifies down to the original function, it's even. If it simplifies down to the opposite of the original function, it's odd. If it doesn't do either of those, it's neither. Many, many, many functions are neither. So don't assume you have to get even or odd. When we simplify this, negative x, that quantity squared is the same thing as x squared. So in both of these, we can do that. Well, if you notice, that is the original function. That is our original f of x. So we would say this function is an even function. Let's try this one. G of negative x is how we determine if this is an even function or an odd function. We replace the x with negative x everywhere we see it, and then simplify. Negative x quantity cubed is the same thing as negative x cubed, right? Because if you cube that -1, you still get -1. And then I have minus x there if I just simplify that plus a negative. If you notice, you factor out a negative here, you get that. Well, this part right here is g of x. So this is equal to negative g of x, negative of what we started with. Now, it's really important to recognize that it has to be negative of the entire function. If just one of these had been negative, then it wouldn't have worked because you have to be able to factor that negative out and have that original function on the inside. This is odd because we got negative of what we started with. Let's take a look at this one. H of negative x. Absolute value of 2 times negative x plus 5. Well, simplifying that, simplifying that, we get the absolute value of negative 2x plus 5. It's really, really important to recognize that when you have an absolute value, you can't just go, you can't take the absolute value term by term. This addition in there doesn't work. Let me give you an example. You have the absolute value of negative 3 plus 4. That's the absolute value of 1, which is 1, right? You can't do the absolute value of negative 3 plus the absolute value of 4. That would give you 7, which is not equal to the 1, which we know it is actually equal to. So do not absolute value term by term. Okay, well, what if we try to factor a negative out of what's inside there? We get that. And we do know that we can... Well, that's definitely not equal to our original function, right? And you can't just bring that negative out front because of the absolute value. So it's not equal to negative of our original function. So we have to say this is neither. This is neither even or odd. What I'd like to do is take a look at what these three functions look like graphically. I'm going to pull up the graphing calculator and we'll take a look at what these look like. When you turn your camera or your calculator on, you should have probably a blank screen. You may have some stuff in there, whatever, clear it out. The way we look at graphing something in our calculator, in case you've never done this, is we go to this y equals in the top left. In there, you may or may not have things. If you do, I've put these three functions in here just to save us a little bit of time in this video. But if you haven't, you would type these in. Let me come down to the y4 and kind of show you how you would do, let's just do this x cubed plus x, and then I'll delete it out. The x is this xt theta n button that you see there. To cube it, we use the caret to the third power. We got to use a right arrow to get out of that exponent plus x. Okay? So that's how I got that. Let me clear that little guy out of there just so you see, so that we're only looking at these three. Then if we wanted to look at the graph of one of these, currently you can see this black box around there. I only have the first function actually turned on. So let's hit this graph button in the top right, and there is the graph of that. If your picture doesn't look like that, it might be because your window is a little bit different. So hit this window button. You can see here the x min is set to be -10. That means the left side of your window along your x-axis is -10. The right side of it, the biggest x value that it shows is +10 with a scale of 1. And then same thing on the y-axis. So if you go back here, this over here would be -10. This would be +10 all the way at the right edge, going by ones there. Same thing, bottom to top on the y-axis. If you wanted to zoom in, because it's hard to see what's going on in that picture, let's zoom, and then you can hit number 2 there to zoom in. It puts a little cursor. You have to hit enter to tell it kind of where to zoom in. So that's the picture that we're seeing here. What this tells us is that our function is only defined from -1 to 1, which kind of makes sense when you think about that function itself. If x is bigger than 1, you get a negative inside that square root. If x is smaller than -1, you get a negative inside the square root. So that's why we're only seeing this function defined on x values -1 to 1. Okay? Remember, we said that this function was an even function. This was part A. This function, being even, should have y-axis symmetry, meaning if I fold it along the y-axis, I get the same picture. And we do see that here. Let's take a look at the second function that we said was odd. I'm going to go ahead and go over and hit enter. That'll turn that one off. And then down and hit enter on that equal sign to give it that box, that darkened box around it. And when I hit graph now, whenever you want to graph something, you hit graph. We have this picture. Let me go zoom, and number 6 is standard. That's that -10 to 10, -10 to 10. You can manually adjust that window by going to window and typing in. If you wanted to go from -5 to 5, you could do that. And hit graph, and you have a similar picture. But I kind of like this zoom standard. Remember, we said this function was odd, meaning it has origin symmetry. I pick this up and rotate it around the origin 180 degrees. I have the same picture. The top part moves down, the bottom part moves up when we do that rotation. So that's origin symmetry. Let's look at the last one. Turn this guy off, and this one on. You could turn all three on at the same time and they would all three graph. They'd all show up. This is that absolute value function. We're going to talk more about how we would know that in the next chapter. But as you can see here, if you fold this on the y-axis, you don't have symmetry. You have symmetry, it appears over a line, where that V, the point of that V is, but that's not the y-axis, so you don't have y-axis symmetry. And certainly if we rotated this around the origin, it's going to make that V upside down over in that third quadrant. So we do not have origin symmetry either. So this is a little introduction, a tutorial on how to graph things in your calculator. Adjusting the window, like using these top buttons up here are super helpful. So adjusting that window, adjusting how you zoom, and so on. The y equals being where you enter the function, you type them in, and the graph showing the actual graph of those. That also helps us kind of visualize these even and odd functions.